Today, we're diving deep into one of the most powerful and, honestly, persistent threats on the web, command injection. It's a crazy vulnerability that can flip a website's most innocent-looking feature into a devastating weapon. So let's break down exactly how it works.
Just look at this line of text. It starts off as a simple network command, right? But with just a couple of extra characters, an attacker can completely hijack a server and steal its most sensitive secrets, like the entire password file. So how is this even possible? How can a simple text box become a master key to an entire system?
All right, here's our game plan. We're going to cover exactly what command injection is and why it's so incredibly dangerous. We'll peek inside the attacker's playbook, see how they can hack systems that don't even talk back, and then, most importantly, we'll talk about building the defenses to stop them cold.
So let's kick things off with the absolute core concept. What are we really talking about when we say command injection? Well, at its heart, it's about tricking an application into betraying the very server it's running on.
The official term is OS command injection. It's a security flaw that lets an attacker send commands not to the application, but through it, directly to the computer's operating system. The application itself basically becomes an unwilling accomplice in its own downfall.
To really see this in action, let's imagine a super typical web tool, like a network diagnostic page. We have our user, let's call her Alice. She types in an IP address to see if a server is online. The application takes her input, runs the pin command, and sends back the result. All good. Everything works exactly as intended.
But now, an attacker shows up to the very same page. They also start with an IP address, but then they tack on something extra. A second, sneaky, malicious command. The vulnerable application? It has no idea. It just executes the first command and then dutifully executes the second one, handing over super sensitive files. The application has just become a digital Trojan horse.
And that right there brings us to why this isn't just some minor bug. The fallout from a successful command injection attack can be absolutely catastrophic. We're talking a complete compromise of the entire system.
I mean, once an attacker can run their own commands, they have the keys to the kingdom. They can get into the operating system, which means they can steal your data, that's confidentiality. They can change your website or mess with your data, that's integrity. Or they can just delete everything or shut you down, that's availability. It all leads to the ultimate prize, complete remote code execution.
And hey, don't just take my word for it. This is not some new, obscure problem. The OWASP Top 10, which is like the official list of the biggest web security risks, shows that injection flaws have been right at the top or very near the top of that list for more than a decade. This is a fundamental, deeply rooted threat. Okay, so we get it. It's really bad. But how does this potential risk actually become a real-world attack? Let's crack open the attacker's playbook and look at the actual mechanics of the exploit. The weakness, almost every single time, is buried somewhere in the code. Take a look at this line of Java. It's designed to take some user input, the CMD and arg here, and run it as a system command. The fatal flaw, the ticking time bomb, is that it blindly trusts whatever the user gives it, stitching it directly into a command that the server is going to run, no questions asked. Now, these attacks kind of come in two main flavors. You've got in-band, which is the easy one for an attacker. They inject a command, and the website's response just hands them the results on a silver platter. But then there's blind injection. This one is much trickier. The application doesn't return any output. The attacker is flying completely blind and has to get creative to even know if their attack worked. So, how do they actually add their malicious command onto a legitimate one? They use these special characters called shell metacharacters, a semicolon, or a double ampersand. These little symbols basically tell the operating system, hey, you're done with that first command? Great. Now run my command. This is the secret sauce of the attack.
And this is where things get really clever. Let's dig into those blind injection attacks, where the server is just giving the attacker the silent treatment. How do they possibly succeed when they can't even see what they're doing?
This is the central puzzle of a blind attack, right? If you send a command to steal data, but the website just loads normally, no error, no confirmation, how in the world do you know if you're in? It takes a totally different way of thinking. Well, this is where attackers show their creativity. They use these brilliant indirect methods. First, they can inject a time delay. If they tell the server to sleep for 10 seconds, and suddenly the web page takes an extra 10 seconds to load, bingo, they know it worked. Second, they can try to make the server create a file in a public folder. then just use their own browser to see if the file is there. And third, the ultimate proof. They make the server phone home by triggering a network request to a domain that they control.
All right, we've seen the attack from the inside out. Now let's flip the script and talk defense. How do you actually protect an application from this kind of hostile takeover?
So, given how simple the attack can be on the surface and how absolutely devastating the consequences are, what are the real fundamental principles for building secure applications that are hardened against command injection?
The defense really comes down to 3 core principles. Number 1, and this is the big one, never, ever trust user input. Assume everything is hostile until proven otherwise. Second, if you can, avoid calling the operating system directly. Most programming languages have safe, built-in functions for things like creating directories. Use those. And third, if you absolutely have to use user input in a command, you have to validate it against a super strict whitelist of known safe values.
You know, the takeaway from all of this is actually pretty simple. The very features you build to welcome users, your application's front door, cannot be allowed to become the biggest backdoor into your entire system.
And that really leaves us with a final kind of sobering thought. This vulnerability is simple in theory, yet it's been a top-tier threat for over a decade. It really makes you wonder, how much of the internet we rely on every single day is running on old code that's never been checked for this one simple and utterly devastating flaw?